Then it goes out to my injectors. Okay? That's how your computer works with fuel. Now, I'm going to go over fuel trim, and then I'll probably go over it again later because everyone's going to have issues with it. But this all kind of works together. That's why it's kind of a long lecture. Sorry. So from 1996 up, this is a PID in your generic and your manufacturer's data streams. And it will be called LTFT. And then you have STFT, short-term fuel trim. Now, when I am open loop, they will be 0. Because this is telling you what it did in relation to the O2 sensors. If I'm not using the O2, it can't tell you. Okay? Now, when I go closed loop, if my number is positive, I am adding fuel. If my number is negative, I'm subtracting fuel. Okay, listen closely, please. It is normal to be between -10 and +10. That is normal. So if I'm looking at fuel trim numbers and they're within 10, either positive or negative, I'm not really concerned about it. That's just normal wear and aging of the car, a little bit of a dirty air cleaner, a little bit of a dirty injector, a dirty throttle plate, 1 pound up on fuel pressure. Completely normal. When it goes above that, I'm getting interested. So, people have a problem with this on how it reacts. Okay. Short term is for fast, quick reactions to a problem that occurs. Okay? Now listen, this is where it gets a little weird. Long-term's job is to keep short-term somewhat centered so it can react quickly. So let me give you a scenario. My O2 voltage is hanging down an average on O211 at 0.2 volts. Is that rich or lean? Lean, low lean, LL. It's below 0.45. So we have to add fuel. So what will happen is, remember, condition command, lean condition, richer command. So, as long as we're closed loop, short term will start moving. +2, +4, +8, +12, +14. All the time adding fuel. Watching this. Now, when it starts getting up here, and how long, it just depends on who designed this thing. This starts getting high enough, long term saying, we got to get this back in more towards the center. So long term will start going up. +4, +8, +12. All of a sudden, you've added too much fuel. Because, now guys, this is a ball peen hammer, this is a sledgehammer. 10 of these is worth about 1 of those. This is a big adjustment, this is a fine-tuning adjustment. So after this goes out so far, now, we're up at 0.8. Whoops, 0.8. So now this baby goes screaming back, and what it wants to do, it wants to get it between -10 and +10. So these are going to play together. And what's nasty is your car learns this. It learns the fuel trim, which is not a problem till you make a change. So you go and you go ahead and you put new plugs in it, and you put a new air filter in it, and you put, maybe you had a little bit of a bad fuel pressure regulator, and you put that in it. Now it's all different. This may or may not relearn. Some cars won't relearn. So that's when you reset the fuel trim, you clear all the memory and let it build new. I had a Mazda, that supercharged Mazda. It would, once it learned, it would just pound its head against the wall. It's going to do the same damn thing over and over, no matter what the O2's doing. So when I was tuning that thing, I was constantly clearing the computer and rebuilding till I finally got the tune right on it. Then it was okay. Okay, guys. This is a great diagnostic tool. Because let's say I look at a car and I'm at idle, okay? And let's say at idle, I'm long-term fuel trim, short-term fuel trim. I'm at +18, +2 at idle. Okay? We okay on that? So what are we doing right now at idle? Are we subtracting fuel or adding fuel? Are we adding more fuel or subtracting fuel? It's positive numbers. We're adding fuel. Now, $3,000 RPMs. What's my problem in the engine? That just told me what the problem is. Is 3,000 RPMs normal? Yeah. It's between +10 and -10. Aren't they? But idle's bad. What does that tell me? And is it bad, rich, or lean at idle? Lean. Exactly. What causes me to be lean at idle but not at 3,000 RPMs? Vacuum leak. You have unmetered air going in the intake. Guys, got to think about this. Now think about a vacuum leak. Whether I got an intake gasket that's sucked in like on a 5.0 Mustang, where they do, right where the two halves meet, or I got a vacuum line that's going up to the AC system that's cracked and sucking air. Okay? Now, think about the volume going through the intake. At idle, do I have a large volume of air going through the intake or a small volume? Small. So the vacuum leak affects the small one much bigger. At 3,000 RPMs, do I have more air going through or less air? More air, but the vacuum leak size didn't change. And it got better when I throttled it. That tells me vacuum leak. Okay? And that's exactly what I do. This is classic case, General Motors, TBI, truck, and it sucked the base gasket in under the throttle body. Very common. Okay? So if I think it's a vacuum leak, I'm going to look at fuel trim at idle. Then in park, I'm going to take it to about 3,000, 3,500 and see if it gets better or worse. If it gets better, hey, I got some kind of vacuum problem. I'm going to smoke check the intake. I'm going to put smoke into the intake and see where it leaks. Now, what about this? And I'm going to go at this is one I had. This is 3,000 RPMs at 70 miles an hour. So I'm test driving this car on the freeway. What's that look like?
Sorry.
What's that?
Sorry.
I'm sorry.
Speed count RPM let 17 is the sorry.
So rich.
Oh, you're saying rich?
Yeah.
Okay, thank you. Guys, these numbers, when I go positive, I'm adding fuel, trying to make the O2 happy. It's down here, guys. Okay, I'm trying to balance the O2 again in fuel trim. If I can't balance it, then I'm going to add or subtract fuel till I do balance it. Now, did I increase or decrease the load on the engine? Between idle and 3,000 RPMs at 70 miles an hour, I increased the load. The more I increased the load, the more fuel it needed. Add fuel. What does that mean? What's that? Not getting enough fuel. What are two main causes of not enough fuel? What's that? pressure from a fuel pump, or maybe low fuel pressure from a restricted fuel filter. Okay, this one was a bad fuel pump. This was a Chevy dually, 1 ton with about 1,000 pounds of tile in the back of it. It was a tile contractor. And he was complaining it was surging at like 70 miles an hour. It's running out of fuel. Okay? So it's telling me, so once I saw that, first thing I did was swap a fuel filter into it. Didn't fix it. Fuel pump. Okay? So this fuel trim, by you varying your load, and you know how you varied it because you're operating the vehicle. You watch what that does. Because it's going to try to make the O2 happy, balanced. What we want for the cap to work. Okay? So we're going to do some stuff with this. You guys are going to get into O2 testing. You're going to get into a bunch of fuel trim stuff. But this is one of your major drivability pits. That's why they don't give you O2 numbers on freeze frame data. They give you fuel trim. Okay? So, I know this is going to take a couple times, guys. People have problems wrapping their head around this. Your book does not go into it well enough. Okay. So, let's take a break. 9 o'clock in here. Figure out, though, for me during that break, gentlemen, where you are in your labs. Okay? Because I'm going to find out where you are in your labs, and then we're going to get going, and we're going to work till like 10:45. We're going to work for an hour and 45 minutes.